Hello and welcome in section 5, generating images with neural style. And in this video we'll get you introduced to neural style transfer. And we'll start with just getting a quick overview of what we mean by neural style. So this is a method to extract content and style from a representation of an image from trained convolutional neural network. And by content representation, we mean the type of representation that we get when we have a trained CNN network, and the higher or the deeper we get into this network, the more kind of the less details we get, but the more kind of a general feel of what we can see on the image we get. So this is the content representation, when we ignore the details, but we can recognize the objects and their arrangement in an image. So this is the content part of neural style. Then we have style representation, and this is slightly different. It still uses the same representations that we have with content representation, but it exists different representations from different layers. And the goal of this is to get the kind of a texture of an image and capture the general appearance, like the color and what we consider style. So those are two components in neural style. And this is the schema that is actually from the original paper that introduced this method. And at the bottom we have the representation of an image of a building, and we can see that on each layer in the middle we have our convolutional neural network, and we have 5 layers here, and we can see what kind of representation or how our network will see this particular image in each layer, right? So when you look at the bottom pictures, you can see that as we move to the right, we are ignoring, so we're going deeper into the network, and we are ignoring those details, and we are focusing, we getting those general appearances, like, in the building, the last picture, it mostly presents the structure, like how this building actually looks like. And on the opposite side, at the top, we have this other method that extracts style. So here we are interested more about blending those representations from the bottom to get the texture of the image. So as we go along, again, deeper and deeper, we get different kind of textures of the image. And of course, the bottom image and the top image are totally different, but we are using the same network to do that, the same pre-trained network to actually extract those to both of the style, but we are using 2 different images for that purposes. So in practice, we find first the content representation of the first image. So this is the building image, the one that have this kind of a structure that we can recognize. And then we also extract from the same network the style representation of the different image. And this is, in previous example, we had this painting and didn't really have a lot of structure, but it has a lot of color, a lot of interesting textures there. And depending if we are extracting content or style, we are using layers, different layers from a pre-trained VGG19 network. And this is the same network that we've used in previous sections, and pretty much exactly the same. And then we are using L-BFGS algorithm. This is this optimization algorithm, and we try to optimize a blank image to match both of those representations. And keep in mind, the actual implementation of this, it's not like a standard Keras API that we're actually using. There's a lot of kind of hacks here, because this algorithm is not included in Keras, it's actually included in SciPy package library. So we kind of are using Keras to do the pre-processing, to get the actual pre-trained network, but then the actual qualization actually happens using this algorithm that is from different library. And to get best results with neural style, the first image has to have a distinct content that we can recognize. And you've seen the examples what we can get with a building, or we have a series of buildings, and you can see the clear structure there, lines and edges that we can recognize. And also it works well with face, and this will be actually working with faces with one face, one picture in a moment. And the other, it has to have a distinct texture, and it's difficult to kind of describe what it means, but paintings in general, and I found that especially paintings that has a almost 3D structure to it, and they produce a really nice results. And you also have to run this algorithm for enough number of iterations, so it has to kind of work for quite some time to get acceptable results. And acceptable results is not well defined goal. You have to like do a lot of trial and error and see what you can actually get with a certain set of content images and also style images.